Hi, welcome to video number 3. In the first video, we designed a programming language, and in the second, we scaffolded our project. And we said that we would begin the third video by implementing a parser. So let's go. We left off last class having written a last video. We wrote a compile function and we wrote a little test for it. So that's where we are right now. We showed that we had 100% test coverage, so that's all good. We should probably begin by cleaning stuff up here and get everything committed. So let's commit and call it scaffolding and push. Okay, now we're nice and clean. Okay, I'd like right now to create a parser. So let's touch in src. We'll make parser.js, and we'll also do parser.test.js in our test folder. Now let's talk about how we want to get all this stuff built, right? So, okay, in the parser, we'll begin by creating a parsing function. So export default function parse. Parse is going to take in some source code. And then it will return what? Well, what does Ohm do? Okay, so Ohm does parsing by taking in your grammar as a string or as a file, and matches it against a candidate source string. So what we'd like to have here is a grammar to which we're going to match against the source code. So the grammar can come in like this. We can create a grammar object by asking Ohm to do that for us. And how should we set that up? Okay, good question. Let's do that now. So what we can do is store our own grammar in a file. So let's touch source. It's pigeon.ohm. And in pigeon.ohm, what we'll do is we'll go back to what we did in video 1, where we went into the Ohm editor and we generated our grammar. Let's copy paste that directly into our Ohm file here. So there we go. We have our grammar, which is now in a file called pigeon.ohm. And what we'll want to do is we'll read that in somehow. Okay. So we're going to use Ohm to do that. Now in the second video, I think we brought in Ohm into our package.json. So let's import it here first. So what we want to do is import everything in the Ohm module from Ohm.js. Okay, VS Code knows that it's there. And one of the things we can import from Ohm is a function called grammar, ohm.grammar. Okay, and ohm.grammar will take in a string representing our grammar. What we can do though is let's just read that in using the file system. So let's import everything as fs from, not form, but from nodes fs module. Okay, we'll start like so, and then we can just, I know you probably shouldn't do this, but let's just read it in synchronously. And this is going to be in source pigeon.ohm. There you go. We now have our grammar. And then what do we do with the grammar? Okay, well, one of the things you can do with the grammar is match. And we can match it against our source code. And then we'll store that in a match object. Now, VS Code is pretty smart about this. It knows that match has type match result. Okay, well, it's never read, so let's actually try to use it. What can we do with this match object? Well, match dot, okay, we can see if it failed. We can see if it succeeded. And we like match dot succeeded, so what we'll say is if the match did not succeed, we can throw a new error object with match dot, what can we use here? Match dot, see, we have match dot message that actually exists. Otherwise, we'll just return the match to the caller. And yeah, I know, believe it or not, that's all you have to do for the parser. But hey, what did we do that was wrong? We actually wrote our parser before writing the tests. That was probably not a good idea. So let's write the tests now. Okay, so in our test folder, the thing we're trying to test is the parse function, and we exported that as a default. So let's bring a parse from source, source / parser.js, bring that in, and we can start with our Mocha testing. And since we're testing the parser here, let's say something about the parser. Okay. What should the parser do? Well, it should accept certain legal programs, and it should reject illegal ones, right? So, I mean, we could start with just a one-off over here, and we can say something like it accepts hello world. And that means that if we would like to parse the, I don't know what it would look like. It's going to look like parse the program that says print hello world with a semicolon. That should be accepted, right? So we probably want to just say that this thing right over here is okay. In other words, it's not empty. It's going to give us a match object of some sort. Now we are testing, so we need to import assert from. Now let's import from node assert strict. And we want to just always make sure we're doing strict assertions over here because that's best. It's not going to matter for this test right over here because we're just testing yes or no, but it will be important later. It should reject certain programs too. So it rejects nonsense, and what kind of nonsense do we have? So we want to assert that it is, well, actually, remember in our parser, if it's okay, we got a match object. Otherwise, we threw an exception. So we want to say here in the parser test, we want to say that it throws. Let's fix this up. We want to assert that it throws. What throws? Well, if we have a function here which tries to parse some nonsense like that, that should not be legal. And if we run npm test right now, what are the chances that it's going to work? I don't know. It probably doesn't work very well. Okay, we have some issues over here with what? Okay, the compiler is alive. That still works. It did not accept hello world. Why? Well, after print, we have a parenthesis over there. And our grammar did actually not allow for parenthesized expressions. How annoying is that? We're going to have to go back and fix that. But that's why we're writing tests, because we'll see that that's the problem. Okay, and now we're able to accept hello world and then reject nonsense. But we want to do some more significant tests than just these two things here. In fact, what's really kind of helpful is to have a whole bunch of tests that show that certain things work and that certain things don't. It's like going to be really nice to have an entire array full of syntax checks and a big array of syntax errors. Okay, let's build up these two folders. And then once we have these things, now, well, here let's put in a first syntax check. Like we want to be able to test that printing hello is a good thing to do. And then in here we can say print hello with a semicolon is going to be good. All right, so we're going to have a case number here. Let's just say something like it can also deal with numbers. Okay, so over here we'll write some code maybe that says, okay, print 8 times 8.3 plus 8.3 0.2 times 10 to the, I don't know, times 10 to the negative 10. And what else works over here? Another form. Oh yeah, just like 3e5, something like that. So these should both work too. All right. So here's two cases where we're going to do syntax checks, and we have a name of the test followed by code that we expect to work. And so what's nice here is we can just go through this entire list. We'll just say for constant, we'll call this the scenario and the source code of syntax checks. And this will be kind of cool. And for each one, we can drop in our it over here and say it accepts the whatever the scenario is. So $ scenario. And then we'll just say, okay, when you parse the actual source. Okay, prettier, clean it up nice. So we're going to read the scenario and the source from syntax checks and then make sure that works. So right now there's two of these things. If everything's okay, good. Okay, test pass, and we have 100% coverage. So you can see it accepts printing hello and accepts numbers. And there are a bunch of other tests that we can do. And let me drop a few of them in right now. All right, so I just threw in a bunch of tests over here with arithmetic operators, relational, some statements, variable declarations, functions of different types, including array types, function invocations, while statements. I just threw in a bunch of things that I hoped would work. So let's test and see how things go. So we do npm test. And yes, this is good. This is good. We have what? 12 different failures, it looks like. Looks like 12 tests failed. That's good. 10 tests passed, 12 tests failed. So let's go through each of them and find out what exactly happened. Okay, so in the first case, we're looking for relational operators, and we see that it doesn't like this parenthesis. And it's at this point we realize something I alluded to in a previous video, which was, you know what, we never handle parenthesized expressions. What's happening over here is that I just have expressions inside of parentheses. I mean, really, that's all it is. So we know we have to go back to own and say, yeah, there's something we actually missed in our primaries. I mean, we actually missed a parenthesized expression. I mean, it's as simple as that. Let's go in here and call this part the parens right here. I'm saving that. Let's see if we still have 12 test failures. And we are down to, okay, good. Look, only 10 failures now. That's much better. It doesn't like multiple statements. That's the first test that fails. And after print 1, x equals 5, x equals sign 5 did not get accepted. Well, this x assignment symbol 5, that's an assignment statement. It's very likely that we just probably forgot assignment statements. Prints variable declaration. Yep, we absolutely forgot our assignment statement. So, I mean, that just needs to be dropped in. I mean, there's nothing else we can do. So let's say an assignment statement. And what's an assignment statement going to look like? Assigned statement is going to, oh, look at that. Figures, okay. Assigned statement would be just a variable. We have variables already? I think we already did variables somewhere, didn't we? Yeah, we have variable down here. So variable, and then our assignment operator, an expression, and yeah, we should probably close that off. Okay. See, there's nothing like writing tests to make you realize that you don't have everything done that you wanted to. Oh, still doesn't like multiple statements. Return with a semicolon. Do we not have a return statement? Oh, all of our return statements seem to require expressions. If we do want to return directly, then this expression here needs to be optional. We can use question mark for optional. Let's put that there and see if we've improved it all. Yeah, we're down to only having 7 failed tests. Okay. First test that fails does not like a function with a body with nothing in it. Interesting. Okay. Should we actually allow that? Let's see. First of all, our function declarations does have a block over here, and a block does require one or more statements. So the whole not returning anything from a function is actually, we're at a choice right here. Do we want to allow this? Do we want to allow empty blocks, or do we want to require statements inside? Well, if we do want to allow blocks to be blank, then we can use a star here, because a star means 0 or more. That might be close to what we want. We can check that later. Ooh, we have more test passing. Okay. Accepts an array type for a parameter array. So we have some problems with arrays. What do we have over here? Expected a colon. Got it. Okay, so this was array type for parameter. We actually did not put a return type for our function. I'm going to put that in there. So let's see where that array type for param. To get this to work. Okay, our language right now is requiring a function return type. So something like void is being required to go there. If we don't want it there, we can change our grammar a little bit too. And I mean, that's a possibility. So we could actually take this part, the colon and the type, and we could make that optional. And if we do make that optional, that test very well may pass. And we are down to just one failing test. And the one failing test here is that we're trying to take an array and then index into it. So this indexing of arrays, let's see if our grammar doesn't actually allow that. In fact, the only time we can put an indexing, an indexing or subscript expression, we call it, has to come after a variable. It cannot come after one of these things. So again, we have a choice. We want our language to be fancy enough to allow this, or do we want to require a variable to go there? Let's for now just require a variable, and we can take that test out, which is possible. Now that does mean our language is a little bit clunky, because if we had a function, something like, hey, I'm going to call a function and it's going to return some sort of an array or something, and then I wanted to index right away, wouldn't be able to do that. We'd have to assign it to a variable, but such is life. So let's take out array literals that can be indexed, can index array literals. I'll just remove that test, run everything, and see what we got. Yes, now all the tests pass. Okay, and then there, we did a pretty good job of taking care of things that we wanted to pass. But now we want to deal with some syntax errors. And here, we'd probably want to write, again, a bunch of things here. So we might say something like a non-letter in an identifier. So we'd like to make sure that this works. And then we want to write here some bad code. So like let, the program might say let a, I don't know, $b equal 1. So that would be an example of something that should not pass. Another thing that should not pass might be a malformed number. So we don't want malformed numbers to pass. And so something like that might be x equals just 2 period, because in our language, the dot has to be followed by some numbers there. And now, just like we work our way through syntax checks here, I'm going to copy paste and say it rejects bad code from syntax errors. And then instead of okay, we want to assert throws whenever we attempt to parse something that we don't want, something that's syntactically incorrect. Okay, let's see if our tests are able to pick up those 2 problems. And indeed they are. So 22 tests pass. Good. Okay, so next step is to just absolutely fill up this array with a whole bunch of crazy cases. However, before we do that, it might be better to say, I mean, we're not interested in just if the test is failing or not. I think we'd like to fail for a certain reason. We'd like to be able to kind of detect what's going on. So let's take a look at this case where I have a non-letter and an identifier. And what does ohm actually do? For a second, I'm going to pretend that this was a passing test and it's going to fail. So I want to see what actually happens over here. Okay, when the test fails, we get a message that says expected an equal sign, but also gives us a line and column number for where the test failed. Like it actually failed at line 1, column 6. So we could actually do a little bit better here. We can say, whenever we make this test right here, we want to say not just what the name of the scenario is and what exactly happened, but it would be really nice to be able to say, like, where this happened. We would like to assert that we really got something, we really got an error at line 1, column 6. And right here, let's take a guess, x equals 2 dot. This semicolon right here should be wrong. So line 1, column what? 1, 2, 3, 4, 5, 6, 7. Line 1, column 7 is where we would expect the error to be. And whenever an exception is thrown, Mocha allows you to dig into the message and check what that message is, or at least match it to something, which is kind of cool. So we can actually put in a third part here, basically the error message. And when we assert throws, a cool thing that ohm lets you do with assert throws is you can actually assert that the error message pattern, or, rather than error message, let's just call this the error pattern. You can match against the error pattern. So let's run this test right now and see how it looks. Yeah, and then everything's right. I mean, it's rejecting these things as expected. In fact, if for some reason I put in the wrong column number right there, Mocha will be able to figure it out, and you can see that it says, "Oh, wait, this doesn't work." Okay, we said we wanted line 1, column 7, but we were expecting 72. See, we expected the 72 over here, but we actually got something at 7. So let's put that back. And now that these things are ready, now we can load everything up with a whole bunch of additional tests. And okay, put in a bunch of different things that I don't want to work. Floating point numbers that are 5e and just stopping right there. 5 minus something, 2 underscore 3. Expressions starting with a right parenthesis. Okay, you name it. There's a lot of stuff here. I even have something that says 1 less than 2 less than 3. I actually want that rejected. And using a while as an identifier is not appropriate. Bad array literal. Sorry, there's a bad paste there. Empty subscripts. Using true and false and trying to assign them. Trying to use numbers as arrays and numbers as functions and new lines and throwing in quotes and things that none of that should work. All right, so let's see how we did. Let's see how our grammar is written. And good. We have a bunch of failed tests. We got 6 failed tests. That's actually nice. The first one rejects a float with an e but no exponent. It says did not match. I was thinking that would happen at column 10, but it looks like it actually happened at column 11. So that was a pretty minor thing. I just had it was just kind of counted wrong over there. So let's run again. Let's find the next failing test. And we are down to 5 failed tests. Relational operators were rejected. It said expected a minus or a plus at line 1, column 6. Okay, so good. So we did 1 less than 2. And then after the lesson, yep, that was not expected to be 3. And that happened at line 16 or column 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Strange that error kind of happened over at line 16. It's kind of not what I really had in mind would happen. But yeah, I thought line 13 it would happen because I thought right here we would reject this right here. Let's come back to this one. Say that. Let's go down to the next one and see what it is. Oh, missing expected exception. So this should reject while is an identifier. So while as an identifier, I misspelled that. While is an identifier. Why did I type that in as for? True is not assignable. Okay, so I wanted to reject true and false over here. And that actually, that was allowed because true and false right now in our language are identifiers. And if we want to reject them, then they have to become keywords. So we should probably consider adding true and false as keywords. So let's do that. Let's make sure that let's do true and false. Let's add these things in as keywords. Can't hurt. True, false. It'll at least get some more of those tests passing. And now over here, I mean, we're trying to get ourselves to not having any tests fail. We're down to six failing tests. The first one is, oh, it doesn't like while true. Okay, that's because true and false now need to be expressions. I almost forgot that part. So we'll put in our true and our false, and we'll allow them to actually appear as expressions. So this leaves us now with three tests that don't fail. This one over here. Oh, trying to assign true for this one. This test true is not assignable, and yet somehow true was assignable. Did I just run that test? What am I looking at over here? Right, so this true error here should be line 1, column 1. And we thought that the error would be at line 1, column 5, but that turned out to be at line 1, column 1. So let's fix that in our test. This is the price you pay when you try to be like super precise. So we're looking for true is not assignable right here. Should happen at line 1, column 1, and same thing for false. It's worth doing. And how many tests fail now? Looks like just one. We're trying to reject a string literal with the new line. It actually happened at line 10. I thought it would happen at line 11. Okay, so that one's going to make that test fail. And now the only one that we have that was a little bit surprising was the association of relational operators. And it probably is not that big of a problem. I mean, I'm seeing that I just thought it was line 13. I just got an error that was a little bit different from what I thought, but it is still being rejected, at least, but almost for a different reason than what we thought. So the reason here is it expected 1 less than 2 less than 3. It's like after that I was expecting a minus or plus. That's real interesting. Let's just take a quick look at the grammar to see why that might be the case. I mean, we did say condition, relational operator, condition, and conditions can allow this thing. I guess this is just an artifact of the way that the parser is working. So we can always say, well, we saw that this error happened at column 16. So technically speaking, I mean, we just could put in a 16 right here, clear that, run this, and we have ourselves a parser that all works. Since the parser works, let's add commit and push so things are clean. And eventually we're going to be moving toward putting the parser into the compiler at some point, because the idea is we want a compiler to first parse, then analyze, then optimize, then generate. But hey, our parser is done, and next up is going to be semantic analysis. Thanks for watching.